The OSI model provides a framework that devices such as routers and switches use to move data. This eases communication between all devices. The model has 7 layers. Each layer has its own task and protocols it uses. As the information travels through different layers, it changes data type. These data types are called protocol data units. Data frames contain information about the moving data. Information is added to the data frame as it passes along in the model as a process known as encapsulation. It is important to note that data moves up and down these layers on both devices that are communicating. When the information is entered by the user, it encounters the application layer first. At this point, the information is simply data. This layer gives the user an interface which they can use to access the network. Some common protocols are File Transfer Protocol, Simple Mail Transfer Protocol, and Simple Network Management Protocol. The next layer the information comes across is the presentation layer, and is still just data. This layer's duties include formatting data as well as providing encryption and compression. Also, this layer employs the use of a redirector which controls the flow of ingoing and outgoing information. The session layer is the next stop for the information, which is still data at this point. The session layer manages transfer sessions by opening, tearing down, and maintaining them. It also controls the responses and requests between devices. Some common protocols this layer uses are PAP, PPTP, and ASP. Layer 4, the transport layer, is where the encapsulation begins. The data obtains a transport layer header and becomes a segment. This layer oversees data transfers by checking the data for errors, controlling the flow of data so the receiving computer's buffer is not overloaded, and reorganizing the data as it comes in. Most importantly, this layer uses 2 ways to move its data, TCP and UDP. TCP is Transmission Control Protocol and is reliable, connection-oriented protocol. What makes it so reliable is that instead of dropping packets with errors, it requests that they be resent. User Datagram Protocol, on the other hand, is connectionless and is commonly used for gaming, where the data does not need to arrive completely intact. Other protocols this layer uses is SPX, RDP, and DCCP. The next layer is the network layer. The segment from the transport layer gets a network layer header and becomes a packet. This layer handles the routing process, which is managing how and where the data will move through the network. It also manages network access control and configures IP addressing. A few of the protocols it uses are IP version 4, IP version 6, ICMP, and IGMP. The data link layer is next. The PDU at this point is a frame. In this layer, the information is encoded or decoded to or from bits. The 2 sublayers in this layer comprise the majority of its function. The first sublayer is LLC, or Logical Link Control. Its role is providing physical addressing and controlling the mechanisms that are used to actually move the data through the physical layer. The other sublayer, MAC or Media Access Control, is also in charge of the physical addressing. Most importantly, though, it oversees the access of the physical medium and uses the carrier sense multiple access with collision detection and collision avoidance. These protocols essentially keep it constant contact with the network medium and controls the data flow across it to avoid collisions. The very first layer, the physical layer, is where the actual transmission of data occurs. The information is in the form of a bit. This layer controls the methods by which the information is transferred, such as wired or wireless. Some of the possible protocols it uses are CAN, Wi-Fi, Ethernet, USB, and Bluetooth.